In this unit, we determined that point estimates, while easy to report and often used, don't represent the variability inherent in sampling when we're trying to estimate a population parameter. An alternative to the point estimate is a 1 minus alpha times 100% confidence interval, which builds upon the point estimate by adding to it and subtracting from it a margin of error. This margin of error is a function of variability, sample size, and confidence. We discussed 3 population parameters that we may want to estimate: the mean or average of the population, the proportion of the population that falls into one of 2 categories, and the variance and also the standard deviation of the population. With respect to estimating a population mean, we found that there are 2 scenarios that we might face. One where the population standard deviation, sigma, is known, and the other where sigma is unknown. When sigma is known, the representation of confidence in our interval is found from the standard normal distribution. We discuss this approach for pedagogical purposes, but generally sigma will not be known. As we often have to estimate the standard deviation of a population with our sample, we typically derive a confidence interval for the population mean when sigma is unknown. In such a scenario, our level of confidence is represented with the t-distribution. The t-distribution was designed for situations where we have to use a sample to estimate the standard deviation and is particularly useful when sample sizes are small. Regardless of the sample size, use the t-distribution to calculate the confidence interval, as the larger the sample, the closer the t-distribution represents the standard normal anyway. The t-distribution has a similar bell-shaped curve as the standard normal distribution, is symmetric, and is centered about 0. But its lone shape parameter is a degrees of freedom parameter that's a function of sample size, or n-1. When estimating the proportion of a population that falls into a particular category, we estimate confidence in the interval with the standard normal distribution. To ensure that the confidence interval doesn't have a negative lower bound or an upper bound greater than 1, the size of the sample that we pull from the population and with which we calculate a point estimate needs to be sufficiently large. The confidence interval for a population variance or population standard deviation has a little different form than the intervals for mean and proportion. This is because the distribution that represents confidence in the interval is the chi-square distribution. This distribution is not symmetric and is truncated on the horizontal axis at 0. That is, the realizations of a chi-square distributed random variable cannot take on negative values. This necessitates a different approach to the lookup table, as we have to look up values on the chi-square axis associated with alpha over 2 in the upper tail and also 1 minus alpha over 2 in the upper tail. Estimating population parameters with intervals is the first step in inferential statistics and paves the way for hypothesis testing coming up in the next unit.